Nuclear power, hailed for its potential to generate large amounts of electricity with relatively low carbon emissions, is a critical component of many nations' energy portfolios. However, the transportation of nuclear materials, as well as the guarantee of their safety and security, poses significant challenges. In this essay, we will explore the complexities of transporting nuclear power materials and ensuring their safety and security throughout the process. Transporting nuclear materials. Transporting nuclear materials involves the movement of radioactive substances such as uranium fuel, radioactive waste, and components for nuclear reactors. These materials are transported via various means, including trucks, trains, ships, and, in some cases, aircraft. 1. Modes of transportation. A. Trucks. Nuclear materials are often transported via specially designed trucks equipped with advanced security features. These trucks are typically heavily armored and equipped with GPS tracking systems, communication devices, and radiation detection equipment to monitor the integrity of the cargo and detect any unauthorized access or radiation leaks. B. Trains. Rail transport is commonly used for the long-distance movement of nuclear materials. Specialized rail cars designed to transport radioactive materials are utilized, featuring robust construction and security measures similar to those of nuclear transport trucks. Century ships. Nuclear materials are also transported by sea, particularly for international shipments. Specialized cargo ships equipped with radiation detection systems and stringent security protocols ensure the safe transport of nuclear materials across oceans. D. Aircraft. While less common, nuclear materials may be transported by air in certain circumstances, such as the urgent delivery of isotopes for medical purposes. Stringent safety measures are implemented to ensure the secure transport of radioactive materials by air, including adherence to international regulations and rigorous cargo screening procedures. 1. Regulatory framework. The transportation of nuclear materials is subject to stringent regulations and international agreements to ensure safety and security. Regulatory bodies such as the International Atomic Energy Agency, IAEA, and national nuclear regulatory agencies establish guidelines and standards for the transportation of nuclear materials, including packaging requirements, labeling, and transport route planning. A. Packaging and labeling. Nuclear materials must be packaged in containers that meet rigorous safety standards to prevent radiation leaks and physical damage during transport. These containers are clearly labeled with appropriate warning signs and symbols to alert transport personnel and the public to the presence of radioactive materials. B. Transport route planning. Transport routes for nuclear materials are carefully planned to minimize risks to the environment and public safety. Routes are selected based on factors such as population density, infrastructure quality, and the availability of emergency response resources. Century security measures. Security measures are implemented throughout the transport process to prevent unauthorized access to nuclear materials and mitigate the risk of theft, sabotage, or terrorist attacks. These measures include armed escorts, surveillance cameras, access control systems, and coordination with law enforcement agencies. Ensuring safety and security. Guaranteeing the safety and security of nuclear materials during transport requires a multi-layered approach that addresses technical, operational, and regulatory aspects. 1. Technical safeguards. A. Container design. The design of containers used to transport nuclear materials is crucial in ensuring their safety and security. Containers must be robust enough to withstand accidents, such as collisions or fires, and prevent the release of radioactive materials. B. Radiation detection. Advanced radiation detection technologies, such as gamma-ray spectrometry and neutron detectors, are employed to monitor nuclear materials during transport. These detectors can detect radiation leaks or unauthorized access and trigger appropriate response measures. Century tracking and monitoring. GPS tracking systems and real-time monitoring technologies enable authorities to track the movement of nuclear materials and ensure they remain within authorized transport routes. Any deviations or anomalies can be promptly detected and addressed. 1. Operational measures. A. Training and awareness. Personnel involved in the transport of nuclear materials receive specialized training on safety procedures, emergency response protocols, and radiation protection measures. Enhanced awareness and vigilance among transport personnel are essential for maintaining the integrity and security of nuclear shipments. B. Emergency preparedness. Robust emergency response plans and coordination mechanisms are established to address potential incidents during transport, such as accidents, spills, or security breaches. These plans involve collaboration between transport operators, emergency services, and regulatory authorities to mitigate risks and minimize consequences. 1. Regulatory oversight. A. Compliance and enforcement. Regulatory agencies conduct inspections and audits to ensure compliance with safety regulations and security requirements throughout the transport process. Non-compliance can result in penalties, sanctions, or suspension of transport licenses, incentivizing adherence to safety standards. B. International cooperation. Given the global nature of nuclear transport, international cooperation and information sharing are vital for addressing common challenges and enhancing safety and security standards. Initiatives such as the IAEA's Transport Safety and Security Program facilitate collaboration among member states to strengthen nuclear transport regulations and practices. Conclusion. The transportation of nuclear materials presents unique challenges due to the inherent risks associated with radioactive substances. However, through rigorous regulations, advanced technologies, and comprehensive safety measures, the safety and security of nuclear shipments can be effectively ensured. By adopting a multi-layered approach that addresses technical, operational, and regulatory aspects, stakeholders can mitigate risks and maintain public confidence in the safe transport of nuclear materials. Continued investment in research, development, and international cooperation is essential for enhancing the safety and security of nuclear transport in an increasingly interconnected world.